Today we're going over factoring a difference of two squares. Let's start with the warm-up, finding the greatest common factor. For our first problem, 2x squared plus 14x to the 6 minus 12x squared y. Start with the coefficient and find the largest coefficient that goes into each number. So the coefficients are 2, 14, and negative 12. 2 is the greatest common factor that goes into each of them. So 2 is the first number we'll pull aside. Second, look at the larger number of the x's of each value of x. So our values are x squared, x to the 6, and another x squared. Well, x squared is the greatest common factor because x squared is a factor of each one of those x's. Then you move on to the y's. Find the largest number of y's for each value of y. Well, we have none, none, and 1, so therefore there's no value of y you can take out of each number because only one term has y. So now you take those coefficients outside the parentheses and divide each term by the GCFs, which is the number outside the parentheses. When you divide each, you will see 2x squared divided by 2x squared is 1. Then 14x to the 6 divided by 2x squared is 7x to the 4th. Bring down the negative, and 12x squared y divided by 2y squared is 6y. If you want to check your answers, just multiply the term outside the parentheses like we're taught by every term. The next one is 32 a to the 6th b to the 4th minus 16 a to the 3rd b to the 2nd. Once again, you break down every single term starting with your coefficient to find the greatest common factor. So for 32 and negative 16 is 16. The GCF of a to the 6th and a to the 3rd is a to the 3rd, and the GCF of b to the 4th and b squared is b squared. So look how I did it this way. You write the GCF on the outside of the parentheses. I have the original equation above and divide it by what's outside the parentheses. You see that 32 divided by 16 is equal to 2. A6 divided by a to the 3rd is a to the 3rd. B to the 4th minus b squared is b to the 1st. And since 16a to the 3rd b squared divided by 16a to the 3rd b squared, they factor each other out, so the answer is 1. Let's look at some perfect squares. We see that x squared is a perfect square because x times x will lead you to x squared. X to the 4th is a perfect square because if you multiply x squared by x squared, that will give you x to the 4th. Look at the next term. We've got 4y to the 6th. Well, the coefficient has to be exact square, and 4 is, and y to the 6 is because y to the 3rd times y to the 3rd is y to the 6th. So any coefficient with a even number will be a perfect square. Now look at these that are not perfect squares. 2x squared. 2 is not a perfect square. So, and x to the 5th is not because it's an odd number. Okay, here's our formula for difference of squares. We used it last time working backwards. Now we're going the other direction. So a squared minus b squared equals the sum of a plus b times the difference of a minus b. So if you had something like 49 minus x squared, well, 49 is a perfect square. It's 7 squared. You have your minus sign, and x squared is a perfect square. So it becomes the sum of 7 plus x times the difference of 7 minus x. Okay, let's continue with our difference of squares. We have a squared minus b squared is equal to the sum of a plus b times the difference of a minus b. If you forget, always put that formula at the top of your paper. Just make sure both values are perfect squares and there has to be a minus sign between them. Determine if the following are perfect squares. So our first one is x to the 4th minus 16. I'll give you a minute to write it down on paper and solve it. The answer is x squared plus 4 times the difference of x squared minus 4. So x to the fourth is a perfect square. X squared times x squared, that becomes our a value. 16 is a perfect square, 4 and 4. Let's try another one. The answer is the sum of 7 plus z to the third times the difference of 7 minus z to the third. 49 is a perfect square, 7 times 7. Z squared is a perfect square, z to the third times z to the third, and it had a minus sign between them. Let's try another one. This is not a perfect square. You could not have factored it because it's a plus sign between the two terms. Let's try one more. Okay, this one is a little trickier. It is a perfect square, but you had to rearrange the order of it. So if you put the 4x squared first minus the 100, then it's a perfect square, and it would be the sum of 2x plus 10 times the sum of 2x minus 10. Now I wrote this with the parentheses in the opposite order, just to show you that it doesn't matter what comes first. The a minus b times the sum of a plus b, as long as what's in the parentheses is right, because if you remember from FOIL, you're multiplying everything from one term by everything in the other term. Read section 6-2 of the text and complete every other even from 2 all the way through to right before the challenge section. I don't have a book here. I just had a CD, so I couldn't give you the exact numbers. I'm also posting this on the school webpage if you need it to go over with homework tonight. Good luck. Sorry I'm sick. I'll see you guys hopefully Wednesday. Bye.